So today is really important that you're paying attention, okay? What we learned today is something that you will do in geometry every day, okay? It's something that you're going to do in Algebra 2 every day. It's something that you're going to do in here almost every day, okay? We're going to be solving, you guys have learned how to use InSolve on the calculators, okay? But geometry, they don't give you calculators, so you can't do that, okay? In Algebra 2, they don't give you calculators, so you can't use InSolve. And it's something that you're going to be doing every day, okay? So it's really, really, really important that you know how to do this by hand. I will show you how to do InSolve, not today, okay? I will show you how to do InSolve so that you can use it for your STAR test, and you can make sure that you get those questions right on your STAR test. Okay, so I will teach you how to do it for that test, but this is so much more than just STAR test, okay, because it's something that you're going to be using after that for a long time. Okay, so it's really important that you understand and that you know how to show it by hand, that you know how to work it by hand, okay, not just InSolve. So an equation, okay, an equation has an equal sign. What do we call it if it does not have an equal sign?
Solution.
No. Remember when we talked about expressions? Okay, that's what we just finished doing, were expressions. Problems that looked like this but did not have an equal sign. And if it doesn't have an equal sign, what do we do with those problems? We simplify. Good. Okay. We distribute and we combine like terms. We simplify expressions. Today we're talking about equations with an equal sign. Okay. A solution is what the variable, what's a variable mean?
The X,
equals
the letter.
The letters. Okay, so your solution, I always ask, what does solution mean? And people say, the answer. Okay, yes, but what does that mean? So the solution is what your variable is going to be equal to, that number. Okay, put the tape away. You should be writing with me. All right, our goal today, okay, anytime you're working math problems, you're always going to have a goal. And our goal today is to figure out what the variable equals. We want to get the variable by itself. So we want to move all the numbers away from the variable. Now this is something that you should have already learned how to do last year. Okay, so it's a little bit of a review, and then we're going to make the problems more difficult. Okay? So it says, example 1, solve each equation showing all steps. Showing all the steps, and then we're going to check the solution in the calculator. Okay, showing all steps. Show me that you know how to do it by hand. Every time that you have to solve something in here, you have to show me that you can do it by hand. Okay, if you want credit. All right, you can't just say InSolve or whatever. Okay, you have to show me that you know how to do it by hand. All right, so we're going to solve this because we have an equal sign. So the first thing I'm going to do is I'm going to draw a line through the equal sign. Draw your line. Every time you solve, I want to see this line. 90% of this solving is nice handwriting and being able to read your work. Okay, are you writing things in the correct place? Can you read what you're writing? That's 90% of this. Okay, and if you can read your writing, it makes it a lot easier. All right, so find our variable on number 1. What's my variable? X, right here. Anytime you're solving, you're going to start with what is being added or subtracted to the x. Well, what's being added or subtracted to the x?
3.
A 3, right? And I want to get this x by itself. So I need to take this 3 and I need to get rid of it. All right? So the opposite of a positive 3 would be what? A minus 3. Now, when I write this minus 3, I'm going to write it right underneath the 3. And then if I do it on one side, I'm going to do it on the other. Minus 3 on both sides. Now, people get confused when we draw a line across. They never know when to draw the line across. Okay? When you've written on both sides, okay, and you're about to do the math, I've written on both sides. Now I'm about to say, okay, what is 3 minus 3? What is 7 minus 3? So now is when I write the line across, when I'm about to do the math. Okay? What is 3 minus 3? 0. Watch how I write this. I'm going to turn them into a 0. Okay, I turn them into a 0. All right? Do I have to write the 0 down here? No. So what am I left with on the left? X equals.
Why don't you cross it out?
Yeah.
Because I want you to understand they don't just cancel out, they actually equal 0. I want you to understand that they equal 0. It's important. Okay? Huh? Do what? Okay, if you want to cross it out, but I put a 0 there. Okay, 7 minus 3 equals what? 4. Is x by itself? Yes. This is my answer. X equals 4. Now it says check the solutions in the calculator. How would I check this? No.
Plug it in.
I plug it in. What does x equal? 4. So just like we were learning in Unit 1, where we had our football game, right? We had our domain in our football game. Right here, x plus 3, that's my football game. So I'm going to take my domain, my 4, and I'm going to plug it into my football game. And when I plug it in, what does it have to have? It's got to have a helmet on, right? It's got to have parentheses. So I'm going to take this 4 and I'm going to plug it back into x plus 3. So parentheses 4 plus 3. And what do I get? 7. So if this side is 7, x plus 3 is 7, does that equal 7? Yes. So this is the correct answer. Because 7 equals 7. So that works. Okay? Okay, number 2. What's different about number 2?
There's no Y.
It's a Y, okay? Does it matter?
It's time.
Hey, you have the car.
Okay, does it matter what letter?
Yeah, no.
No. Does not matter what letter. Okay? Does not matter what letter. Alright, so now I'm looking at 8y equals negative 24, and somebody said now we're multiplying, right? If I find my variable, we start with what's being added or subtracted. Is anything being added or subtracted? No. Okay? Now, what operation is happening here? Multiplication. So over here I had a plus 3, so I have the opposite of minus 3. What's the opposite of multiplication? Dividing. You draw division. A fraction bar. So I'm going to draw a fraction bar. And what am I going to divide by? What's being multiplied? 8. 8 is being multiplied. What am I going to divide by? Y. Or 8. Sorry. I was about to say something about Y. And what I do to one side, I do to the other side. Fraction bar 8. Do I put a Y with the 8?
No.
No. You do not put the Y with the 8 down here. Okay, because that would cancel out the Y too. We only want to cancel out the what?
8.
Just the 8. I want to keep the Y over here. Okay? And if you divide by Y, you're canceling it out because the same thing on the top and bottom. If I put 8 divided by 8 in the calculator, what do I get? 1. Okay? Do I have to write the 1 in front of Y?
No.
No, so that's why they cancel out, because they equal a 1. Alright, and if I put the Y down there, that messes everything up. Then that moves it to the other side. I don't want to do that. I want to keep the Y over here. Okay, so we don't want to put 8Y. Just the 8. Alright, equals. Then I need to know what is negative 24 divided by 8. And I get negative 3. Is Y by itself? Yes, that's my answer. Questions? Okay, look at number 3. We're solving, so I need to draw my line. Alright, find your variable. Here's my variable right here, x. We start with what is being added or subtracted to the x. What's being added or subtracted?
-4.
-4. See the x? -4. So that's what I'm going to start with right here, this -4. And what's the opposite of -4? Okay, make sure you're writing nice and neat. So right under that -4, I'm going to put a +4. And what I do to one side, I got to do to the other. Okay, now I'm ready to do the adding. So now we're going to draw our line because now we're adding. And I start with -4 + 4. What does that give me?
0.
They give me 0. And what am I left with?
7x.
7x equals.
7.
And 3 + 4 gives me 7. Okay, is x by itself? No. Here's my x. There's a number with it. What operation is happening right here?
Division.
This is multiplying, so I need to draw my fraction bar, my divide. Okay, because fraction bar means divide. If I divide, okay, what am I dividing by?
7.
The number right in front of the x, which is 7. What I do to one side, I do to the other. What's 7 over 7?
7. 1.
This is a 1x, right? This all equals 1x. Do I have to write the 1 in front of the x?
No, you just write
No,
that.
so I just write x equals. Now, do I have to write the 1 over here?
Yes.
Yes, because I need to know that x equals 1. Ooh. I forgot to check number 2, but we are going to check number 3. Okay, so we're going to take 1 and we're going to plug it into the football game. And when I plug it into this x, I'm going to say, okay, when I plug the 1 in for x, does that give me 3? So if I take 7, and when 1 goes in, it's got to have a helmet on. 1 minus 4 gives me 3. So this side is 3. Does that equal 3? Yes. Okay, look at number 4. What's different about number 4?
It's switched.
What's switched? What does that mean?
It's flipped. It's flipped.
The answer is not going out.
Is there an answer right now?
Yes. It's
Well, like, the
is the solution.
The solution is
Not the
whatever it
solution.
equals to.
Sorry, no, never mind. The equal sign.
Okay, my x is where?
Right side.
On the right side. Is that okay?
No. That's no bueno.
Yes, it is okay.
It's okay, right? It's okay that the x is over there. Are we going to do anything different?
No.
No, we're still going to get x to the side by itself. So I'm going to take all the numbers on this side, and now I'm going to move them to the left. Stop. You're going to go back to your seat. Both of you. Okay, find your x. Right here. What's being added or subtracted to this x? 6. Okay, now, this subtraction sign, does it go with the 6 or the 2?
2.
The 2. So is this 6 positive or negative? Right now it's a positive 6. So what's the opposite of a positive 6?
Negative.
A minus 6. And what I do to one side,
You
got to do to the other side. Now I'm ready to subtract, so I'm going to draw my line. And I'm going to work left to right like I'm reading a book. What is 10 minus 6? 4. Equals 6 minus 6 is what? 0. And I'm left with what?
2.
Not just 2x, but negative 2x. Okay, what operation is happening with the x now? This is multiplying, right? So I need to do what? Divide by what?
2.
Whatever is in front of the x. If it's a negative 2, you divide by negative 2. If it's a positive 2, you divide by positive 2. This happens to be a negative 2. So when I divide, I need to divide by a negative 2. Okay? What I do to one side, I got to do to the other side. Okay, 4 divided by negative 2 gives me negative 2. equals -2 divided by -2. Gives me 1, which equals x. Is x by itself? Yes. Did we write our answer like this? How do we have to write it?
X equals.
X equals. So this is x equals -2. There you go.
So when you divide it, how is it not like positive 2 if before it's like it's higher?
Because we're not, that would be adding and subtracting. Right now we're multiplying and dividing. Anytime you divide, if it's a positive and a negative, you always get a negative. If it was negative and negative, then you would get positive. Okay. Okay, look at number 5. Yes.
Whenever they check our answers, they put the equal sign in.
Oh, sorry, I forgot to check it. No. The equal sign just tells you what, when I plug in -2 on this side, I need to know that if it equals 10, you got the right answer. If it equals anything else, you got something different. So when I plug it in, this 6 minus 2x, that's the only part of the football game. So I would do 6 minus 2, and then instead of x, I would put -2. And I get 10. So then it's 10 equals 10, and that's correct. 10 does equal 10. If it was 10 equals 12, does 10 equal 12?
No.
Is $10 the same thing as $12?
No.
No. Okay, so that wouldn't work if I got a different number. Okay? Thank you for reminding me to check my answer. Okay, here we go. Number 5, what's different?
Decimal.
Decimals, does that mean anything?
No.
No. I'm going to be doing the exact same thing. What are you doing? Yeah? What are you doing? Okay, why are you working right now ahead? Should you be working ahead? No, we don't work ahead, Rob. We take notes. We work together. Okay? Draw my line. Do decimals mean anything different?
No.
No. Find your variable. What's being added or subtracted to the variable?
-5.
Negative 5.7 is being subtracted, right? So opposite of that is plus 5.7. What I do to one side,
I do to the other.
do the other. Now I'm about to add, so I'm going to draw my line. 1.5 plus 5.7 gives me 7.2 equals, okay, let's do the other side. Negative 5.7 and positive 5.7 give me what? 0. And I'm left with 1.2y. Is y by itself?
No.
No. So these are being multiplied. Option to multiply is divide. So I draw my fraction bar, because that means divide. And I divide by whatever's right in front of the y, which is 1.2 on both sides. So 7.2 divided by 1.2 gives me 6 equals y. But can I write it like that? No. There you go. Okay, check it. Plug in the 6 for y. So 1.2 parentheses 6 minus 5.7 gives me, is 1.5 equal 1.5?
Yep.
That's right. All right, number 6, what's different?
Division.
It's got dividing in it, right? You're still going to do your problem the exact same way. Draw your line. Find your variable.
Plus here.
N. Okay, n is my variable. I'm still going to do it the same way. What's being added or subtracted to the n? A plus 2. So I need to minus 2 first on both sides. You always do what's being added or subtracted first. Now I'm going to subtract. Draw my line. 2 minus 2 gives me 0. And I'm left with n over 7 equals. What's 6 minus 2? 4. All right, now look at your n. It's a fraction bar. What's that mean? Divide. What's the opposite of dividing? Multiplying. So I'm going to multiply the top by 7. And I'm going to multiply 4 by 7. What I do to one side, I got to do the other. Okay. So when I multiply this, Okay, this is really 7n over 7. If I have something on the top and the bottom, what does that equal? Same thing on top and bottom gives me what?
Same answer.
They give me what?
1.
They give me 1. See how 1.2 and 1.2, same thing on top and bottom, we cancel them, right? Well, I've got 7 on top and 7 on bottom. What happens to those 7s?
They cancel.
They cancel. Now I'm left with
4
n equals 4 times 7 is 28.
Oh, yeah.
Questions?
No.
Okay. 7. What's different about 7?
Plus,
It's got parentheses, so draw your line. All right, where do you think we're going to start on number 7?
3
Parentheses, so 3. Yes, and what am I going to do with that 3?
times it.
What's that called?
Distribute.
Distribute. Zayden, pick that up. Okay, I'm going to distribute the 3. So 3 times a gives me what?
3A.
3a. Make sure you're writing nice and neat. Read your handwriting. And then I take the 3 and I multiply it to the
Negative.
-2, and I get what?
-6.
-6. Can I do anything else over here?
No.
No, so I'm going to bring everything else down. Okay, from here down is what we've been doing, so I want you to finish this problem. Find your variable, what's being added or subtracted. All right, find your variable. What's my variable? A. What's being added or subtracted to A?
6.
-6 or a -6. What's the opposite of a -6? A +6. Good. +6. What I do to one side, do to the other. Now I'm adding, so I'm going to draw my line. All right, -6 and +6 give me what? 0. And I'm left with 3a over here equals -9 and 6 is
-3.
-3. Is a by itself?
No.
No, so I got to divide by what is right in front of a.
3.
3. A equals -1. Okay, let's check it. Everybody check this with me. 3, parentheses, because there's parentheses in the problem. Now, I plug in -1. What's it have to have? Its own parentheses. -2. Gives me what? Do those work?
Yes.
Yep.
Oh.
So that's right.
Um,
All right, number 8. What's different about number 8?
They have 2 X's.
It's got 2 x's now, right? So what do you think I'm going to have to do first? Combine my like terms. Now listen to what I'm about to say. This line, that pink line, is like a wall barrier. It's a wall barrier, okay? You can only combine like terms that are on the same side of the line. Let me say that one more time. You can only combine like terms that are on the same side of the line. Okay, so let's start with 5x. What's its like term? 2x. And I'm combining, so I'm going to add 5 plus 2. Gives me 7. So that is 7x. Now, -3 and -31, they're like terms. Can I combine those? No, they're not on the same side of the line, so I just got to bring them down. Okay, from here down, I want you to finish the problem. All right, here's my x. What's being added or subtracted to it? A -3, so I need 2 plus 3. Negative 3 and plus 3 give me 0. I'm left with 7x equals. And then I do negative 31 plus 3 gives me
28.
negative 28. Is x by itself?
No.
No. What operation? Multiply. So I need to divide on each side. X equals negative 4. Okay, if we were to check our answer, how would I check it?
Put it in both of the x's.
I gotta plug negative 4 into both x's. And when I plug it in both times, it's gotta have its own set of parentheses. So 5 times negative 4 minus 3 plus 2 parentheses negative 4. Plugged it back in. Gives me, is that right? Yes. Okay, number 9. What do we notice about number 9?
It has
Oh.
parentheses and it has 2.
And they're close.
Like terms, right?
Yeah.
Okay, so first we gotta draw our line. What do I start with? Distributing. What am I going to distribute? 3. So I take the 3 times x and get 3x. Make sure you're writing nice and neat. Then I take the 3 and I multiply it to the negative 2. What's 3 times negative 2? Negative 6. What do I do with this plus 4?
You combine it with negative 6.
I'm going to bring it down first.
Yeah, right.
Bring everything else down. Because I use the parentheses, now I bring everything else down. Now, Levi, you told me these are like terms, right? Negative 6 and 4.
Yes.
Is 7 a like term?
Mhm.
No. It's on the other side of the wall barrier. Cannot combine them. So now I'm going to add negative 6 and 4. And I get negative 2. So I've got 3x minus 2 equals 7. Okay, from here down, you guys finish the problem. I'm going to finish it up here, but you don't look up here until you're done.